Today's lesson, we're going to be talking about logarithmic functions. Let's get started. Logarithmic functions and exponential functions are inverses of each other. Here I've drawn the graph of y equals 2 to the x and y equals log base 2 of x. And they're inverses of each other. We're familiar with this exponential growth. Y equals 0 is our horizontal asymptote and our y-intercept is 0, 1. Well, if they're inverses, they're going to be mirror images over the line y equals x. That's a line with the slope of 1 through the origin. That means that we can switch our domains in range. So 0, 1 becomes 1, 0. A horizontal asymptote at y equals 0, if we think about folding this over this diagonal line y equals x, that asymptote will be down here. Now, a vertical line has the form x equals 0. We see the point 1, 2 becomes the point 2, 1, and you can confirm that by plugging in 1 for x and getting 2, or plugging in 1 for x down here and getting 0. Notice our x values here cannot be negative. Maybe you've been saying for years that you can't take the log of a negative x. Well, here is our graph y. Look, there's no x's. We have an asymptote at x equals 0. There's no values to the left of 0 or less than 0. Here's a graph of 3 different log functions. Notice they all have this shape here. Log 10 is the common log base 10. You usually don't have to write the 10. I just did for demonstration purposes. Log 10x. Well, it goes through this point 1, 0. Why? Because if I put a 1 in for x, which is my x coordinate, log 10, 1. Well, remember, the answer to a log problem is the exponent. We're saying 10 to the 0 is 1. So 1, 0 is my point because I put a 1 in for x. If I put a 10 in for x, I'm saying 10 to the what equals 10? Well, 10 to the 1 equals x, so my point is 10, 1. So I go through 1, 0 and 10, 1. Similarly, for the red graph, y equals base 3x, log base 3x, log base 3 of 1 is 0 because 3 to the 0 equals 1, so my point is 1, 0. It goes through 1, 0. And log base 3 of 3 is 3 to what power gives me 3? 3 to the 1. So 3 and 1 are my x and y, and I go through 3, 1. Very similarly, log base 2 of 1 is 0 because 2 to the 0 equals 1. So I'm going to have a point of x is 1 and y is 0. There it is. And log base 2 of 2 is 1 because 2 to the 1 equals 2. So I'm going to go through the point 2, 1 right there. From our last graph, we see that it's important to know for y equals log a x, for a is greater than 0. Log a to the 1 equals 0 because a to the 0 is 1. The answer to a log problem is the exponent. And log a to the a is 1 because our base a to the 1 equals a. The natural log has base e. So f of x equals log base e x, where x is greater than 0, or f of x equals ln x, x is greater than 0. Those are the same thing. Let's make some observations about the graphs of logarithmic functions. The graph of y equals log base a of x minus k, provided that k is greater than 0, k is positive, is identical to y equals log base a of x, but moved k units to the right and has a vertical asymptote at x equals k. So a negative k, if you're subtracting something, is just the opposite of what you think. You're going to move it to the right. And the graph of y equals log a, x plus k, again k is positive, is identical to y equals log a x, but move k units to the left. We're adding k, moving to the left. We're subtracting k, we move to the right. If it's associated with x in parentheses, it's the opposite of what you would guess. It has a vertical asymptote of x equals negative k. For example, if I have my parent function y equals log x, or log base 10x, I know that goes through 1, 0 and 10, 1 and has a vertical asymptote at x equals 0. Well, if I want to graph y equals log base 10 of x plus 3, that's going to move me 3 to the left. So my vertical asymptote goes from x equals 0 to x equals negative 3, and my intercept goes from 1, 0 to negative 2, 0, and my 10, 1 goes to 7, 1. I can draw my curve, shifted to the left 3. I can also shift this curve to the right. Y equals log 10x is my black curve, it's my parent function. If I want to move to the right, I'll have y equals log base 10 x minus 2, which will shift my vertical asymptote from 0 to 2, and my intercept from 1, 0 over 2 would be 3, 0. I know it doesn't look like the same curve, but it is the same curve. Now that we know what a logarithmic function looks like, we can make some observations about its translations. The graph of y equals k log a to the x, where k is greater than 0, is identical to y equals log a to the x. But, notice, we're multiplying by a constant k. Now, if k is greater than 1, we're going to stretch it along the y-axis. And if k is between 0 and 1, but positive, we're going to shrink it along the y-axis. If k is negative and less than negative 1, so its magnitude is great and it's less than negative 1, we're going to first flip it about the x-axis and then stretch it. If k is negative, but it's a small number, meaning it's close to 0, meaning it's between 0 and negative 1, it's a fraction less than negative 1, it's a fraction between 0 and negative 1, we're going to flip it over the x-axis and then we're going to compress it or shrink it. So, greater than 1, stretch it. Between 0 and 1, shrink it. Less than negative 1, flip it and stretch it. Between negative 1 and 0, flip it and shrink it. For example, if I have my parent function y equals log base 10 of x that goes through 1, 0 and 10, 1, it has a vertical asymptote at x equals 0. If I graph y equals, my k is positive and greater than 1, it's going to stretch it. Y equals 8 log 10x is stretching it. See, this red function is stretched out. It now goes to the point 10, 8. If I have y equals, my k is between 0 and 1 and it's positive, y equals 1/8 log 10x is going to shrink it. I'm still going to go through 1, 0, but instead of 10, 1, I'll go through 10, 1 over 8. But my parent function again is y equals log base 10 of x. Here it is. Y equals negative. Now my k is negative and its magnitude is great. It's far away from 0, negative 8. This is going to flip this parent function. So now it's like this, and then stretch it out. And it gives me this green function through 1, 0, and 10, negative 8. If my k is between 0 and negative 1, I'm going to flip this parent function and then shrink it down. So instead of going through 10, negative 1, I go through 10, comma, negative 1/8. The graph of y equals log ax minus, the whole thing minus k, where k is greater than 0, is identical to our parent function y equals log ax, but moved down vertically k units and has a vertical asymptote at x equals 0. The graph of y equals log ax plus k, now the k is outside of the log, where k is greater than 0, is identical to our parent function, again, y equals log ax, but move k units up vertically and has a vertical asymptote at x equals k. For the log function y equals log base 10 of x, if I take this translation, y equals log base 10x plus 5, I've moved it up 5. My k is positive. If my function in orange is the parent function with the negative 5 for k, that just means I'm moving it down 5. Notice my points go from 1, 0 to 1, 5, and 1, 0 to 1, negative 5, and 10, 1 to 10, 6, and 10, 1 to 10, negative 4. Each case, the vertical asymptote remains x equals 0. The graph of y equals log a, now in parentheses, negative x, is identical to y equals log ax, but reflected about the y-axis and also has a vertical asymptote at x equals 0. And here's an example of that concept. On the right-hand side, I have y equals log base 10 of x that goes through 10, 1 and 1, 0. If I want to graph y equals log 10 of negative x, well, we know that our x, in this function here, our x has to be greater than 0. Well, over here, our x has to be less than 0. If I put in a negative 1, the opposite of negative 1 is 1. And we know that we can only take a log of a positive quantity. So here, interestingly, I can only use negative quantities or negative numbers so that when their sign is changed, they become positive. That's why I'm stuck on the negative side over here. 10, 1 goes to negative 10, 1. 1, 0 goes to negative 1, 0. The graph of y equals log a, k minus x, where k is greater than 0, is identical to y equals log ax, but reflected about the y-axis, which is no surprise because we see the negative there, but move k units to the right, which may be surprising because you may want to write this as y is equal to log base a of negative x plus k, and then say, well, this plus should be the opposite of what I think, and I'll move k units to the left. But that's not the case at all. We're going to move k units to the right when the k is in front like that. Let's consider graphing y equals log base 10. Instead of a, let's go base 10 of 3 minus x. Well, first, log base 10 of negative x is just going to be flipped over the y-axis. Still have my asymptote at x is equal to 0. What is this 3 going to do? It's going to move me now 3 to the right. So here I've moved this dotted graph 3 to the right, and here's my final answer for y equals log 10, 3 minus x. It's flipped and then it's moved to the right with a positive 3.